All right. So I am more excited to talk to you today about 6 gigahertz than I think I have ever been. This is a really special day for me personally. I know also for a bunch of folks here at Aruba. I'm guessing before 9 a.m. It'll be a special day for all of you. And I'd like to think this is the only presentation you're going to remember today. It's been 55 weeks since the FCC voted unanimously to open the 6 gigahertz band. It's been 134 weeks since I gave the first of, what have been dozens and dozens of talks on this subject back at Wi-Fi Trek in San Diego back when we were all traveling. And it's been about 58 months since the first members of the 6 gigahertz coalition got together to start the work to open up the band. Here is the unprecedented global state of progress in those 55 weeks. I mean, this is unprecedented in terms of the speed and breadth and harmonization for spectrum globally. Just last week, you've heard me say in the past that this is literally almost changing by the day sometimes, and certainly by the week. So Costa Rica and Peru both issued decisions in the last 7 to 10 days to open all 1,200 megahertz of the band. So you can see that so far in the Americas, we are every country that has approved the band, and there's quite a few of them, has approved all 1,200 megahertz. This brings the total number of countries that have decided to open the band to 38. And those countries are home to 1.2 billion people, and that's 16% of the global population. In addition to that, the blue countries, the light blue countries, are in some stage of a regulatory process. So there's 31 more countries right now, accounting for another 2.2 billion people that are studying how to open the band. So there has never been a faster rollout of so much spectrum that's going to touch so many people in real life and solve real problems in an affordable way. And I'm guessing at this point, pretty much everybody in the audience here, certainly the field day crew, is probably pretty well briefed on this subject. And I'm guessing pretty much most of you have sat through at least one, if not more than one, of my presentations on this in the past. Show of hands. Yeah, I thought so. So at Aruba, we're always trying to figure out how to use your time here well and to do things that are really special for Network Field Day. So Ano and I have some good news and we have some great news. The good news is we're going to throw out the script and we're going to spare you the usual 6 gigahertz lecture. And the great news is that we are done being all talk. It is time for some action. The engineering team here has been working very hard on our 6E products. They are really proud of their progress, and the Aruba QA team has been running laps in their QA, in their RF cages. And we would like to give you a chance to see for yourself what kind of performance you can expect from a next generation tri-radio 6E AP. Would you like to see 6 gigahertz in action? Yeah, I thought so. Before we get ahead of ourselves, we are not announcing a product today. We want to give you a taste for the capability. We're not even going to put it in the top gear. We're gonna run the track at probably 6th gear. So this device actually goes even faster. But let me turn it over. So for once in a 6 gigahertz presentation, I'm going to sit down. And I'm going to turn it over to our pit boss, Pratik, who is going to show you that we recorded this on Monday. We would have done this live if we were all together, but with COVID protocols, we couldn't have camera crew in the RF cage. So anyway, Pratik, let's see what she's got.
Hi everyone, my name is Pratik and I'm going to give you a demonstration of the cool Wi-Fi 6E technology on our prototype access point. Now, in order to run the test, we have the access point operating in 3 bands, 5 GHz, 2.4 GHz and the 6 GHz. We will have one client connected to each band of the AP, and then we will run UDP downlink traffic to the client using Ixia Chariot application. So let's get started. We will start with the 6 GHz client first. So the 6 GHz client that we have is an Intel AX210, which supports Wi-Fi 6E. We will connect the client to the Wi-Fi 6E SSID. Oh, well, I forgot one thing. We also have a sniffer. So what we can do is we can check the capabilities of the client and the AP while the client is connecting. So let's start the sniffer, connect the client, and see what's going on. So I'm going to filter out the association request and response frames. This is the association request frame from the client. And in the association request, we can check the 6 GHz band capabilities. And these are pretty much default. We can also check the 6 GHz band capabilities from the AP in the ASOC response frame. So there it is. We have the 6 GHz band capabilities. And we can also check the operation information element, which tells us about the channel. So we are operating in channel 1, and it's an 80 MHz channel. So now that the Wi-Fi 6E client has connected, we will start the traffic and measure the throughput. So while the traffic is running, we can also check the controller dashboard, which will give us some info on the client. So as you can see, the only client which is connected to the access point is 192.168.1.129, which is connected in the 6 GHz band. This is a 2x2 prototype access point, and whether it's 6 GHz or Wi-Fi 6 5 GHz, with an 80 MHz bandwidth, we can expect the throughput to be a little more than 1000 Mbps. There it is. So the test finished, and we got a throughput of 1035 megabits per second. And now we will run the same test in 5 GHz and 2.4 GHz. So for 5 GHz, we are using Intel AX200 client. It's a Wi-Fi 6 client, and it cannot scan the Wi-Fi 6E SSID because it can only operate in 5 and 2.4 GHz. So we can see in the list of networks, there's no Wi-Fi 6E SSID, which we saw it earlier with the AX210 client. So we'll connect this client to the Wi-Fi 6 5 GHz. I will disable the IP address of the 6E client and enable the IP address of the Wi-Fi 6 5 GHz client and run the test. We expect the throughput to be similar. It's a Wi-Fi 6 5 GHz client, and we expect it to be pretty much same as what we saw with the Wi-Fi 6E. And now, as we can see, now we have two clients connected. We still have the 6 GHz client, and now the client that we just connected is in the 5 GHz band. So for 5 GHz and 6 GHz, we are using an 80 MHz channel. And there we go. So we got a throughput of 1040 megabits per second. And finally, we will run the test in 2.4 gigahertz. So we will connect another Intel AX200 client in 2.4 gigahertz this time. So this is the third client. It's an AX200 client. It cannot see the Wi-Fi 6E SSID as expected. We'll connect it in the 2 gigahertz band. For 2.4 gigahertz, we are using a 40 megahertz bandwidth. So I'm going to disable the 5 gigahertz IP and then enable the 2.4 gigahertz IP address. The test will run for a minute and we will measure the throughput. While the test is running, we can look at some of the controller radio stats that can tell us what MCS the AP is using and what bandwidth it is sending the frames at. So let's check it out. This is the controller. They can use the show AP debug radio stats command and then give the radio ID. Radio 0 is for 5 gigahertz. For example, we want to know what MCS the AP used for the transmit data frames. And as you can see, most of the frames went out at MCS 11. Likewise, we can check the NSS. It's a 2x2, so most of the frames went out at NSS 2. We can check the same for the 6 gigahertz radio, which is radio 2. And do the same thing. So yeah, again, most of the frames were at MCS 11. And also check the bandwidth. As expected, 80 megahertz. Oops. And NSS 2. Now the test has completed for 2.4 gigahertz and we got a throughput of 417 megabits per second. So now we have clients connected across all 3 bands, and what we'll do is run the traffic to all the 3 clients together. There we go. So I've started the test. And from the controller dashboard, now we can see there are 3 clients, one connected in the 6 gigahertz band, one in 2.4 and one in 5 gigahertz band. While the test is running, we can check the radio stats for the 2.4 gigahertz as well. So that's going to be radio 1. Yeah, so for 2.4 gigahertz, we are using 40 megahertz bandwidth. So most of the frames went out at 40 megahertz. And mostly MCS 11 was used. It's a mixture of, well, quite a few frames went in MCS 10. It's a 2.4 gigahertz channel. Okay, so the test just completed, and look what we got. We got 906 megabits per second for the 6E client, 902 megabits per second for the 5 gigahertz client, and 396 megabits per second for the 2.4 gigahertz client. If we combine them together, this gives us a throughput of 2205 megabits per second. That's really cool. And we can see that the Wi-Fi 6E and the 5 gigahertz Wi-Fi 6 clients the throughput was not really impacted. Well, there are 3 different bands, and the AP is able to operate in the 3 bands simultaneously without really impacting each band.
Yeah, I was kind of curious what the performance looks like in a more adversarial RF environment. Seeing that in a test chamber is pretty sweet, but my experience with Wi-Fi has been plagued with many things such as poor planning, poor AP placement, and lots of, I think Tom called them meat bags walking around, attenuating signals and all of that. Have there been tests similar to this done in a more real-world environment at this point?
Yeah, I can let Pratik maybe answer the questions about the specific test, but yeah, there's no doubt this was in an ideal environment. As you saw, most of the rates were at MCS 11. We had strong signals, we had perfect MIMO going on, and all of that will obviously be affected in a real-world environment. But this sets a great baseline, I think. And the other point I also do want to make is we're only showing HE80, so 80 megahertz channels. We haven't even touched on 160. So I think the baseline is very high. Sure, real world will be significantly below this, no doubt. But it's a great starting point. Pratik, do you have any idea what the real world test results will look like?
Yes, no, that is still ongoing process. This was pretty much the baseline, and we are going to do that next.
I have a question as well. So I was a little confused by some of the displays that said 160 megahertz, and yet another part of the test results said 80 megahertz. So
yeah, I think I can answer that. The client card that we were showing when we were associating the client, it just shows the name and type of the client, and this is an 160 megahertz capable Intel client card. But we were connecting it at 80 megahertz channel from the AP.
Okay. And then on the 2.4 gigahertz, I think using 40 megahertz is kind of optimistic.
Absolutely.
For real world deployment.
Yeah, I knew somebody was going to bring that up. HE40 is, of course, not somebody that, certainly anybody in enterprise, in my home I may use it, but in enterprise environment, you would not deploy 40. Nobody does. Right. But we wanted to highlight what the current state of the hardware is, what we can demonstrate today, how far we can get, and we wanted to maximize that, of course, for the sake of the demo. Plays into what was said before, right? This is optimized and idealized. Real world will be a little different.
Yeah, that was going to be my next question is what was RSSI and what was SNR? And for a future video, when you do the real world tests, it'd be really useful to include those characteristics.
Yeah, I don't know if we captured that, but I can almost guarantee you that the SNR was going to be awesome. 40 or better for sure. Signals were strong. It's in a cage. But this is what we do initially to test our platforms in a lab in the ideal environment. We do the same on the other platforms, right? I mean, the contrast with the Wi-Fi 6 AP is, with the current state of what's available in the business, is very clear.
Super, thank you.
Okay.
I have a real quick question as well. Sure. Showing the speeds, they look great in the 3 bands, but I was wondering, again, real world, is there any sort of hierarchical band steering, like we have band steering, 5 gigahertz and 2.4 today? Once we add the 6, is there going to be any sort of control on the balance where we can actually take advantage of the 3? Or because, as you said, real world is going to be different, but I was just wondering about that.
Yeah, I do not want to take any shortcuts on maybe some product announcements or features that we might be talking about in the near future. But there's no doubt that we'll do whatever we can to make sure that 6 gigahertz capable clients, for example, will connect to the 6 gigahertz band and take advantage of all the amazing capacity there. And there will be some other characteristics as well to make sure that you get the ideal and the best possible performance even in the real world.
Yeah. Hey, Otto, if I can, I guess, break my embargo. So just another word on that. So yeah, if for those of you that have seen my talks on this, where we went into, we talked about how discovery occurs. It is the case that most clients are going to discover 6 gigahertz radios on one of the other bands. And that's because there are so many channels in 6 gigahertz that it's just not feasible to scan them all in the amount of time available. So that has implications for the algorithm that vendors have used historically for doing things like client match and so on. So there's going to be, I think, some interplay of the new features that are in 11AX with client match type capabilities. But Anna's exactly right. The goal is to deliver the same type of experience that you're used to in the current bands and extend that to 6. But we're going to have a little bit of work to do with the mobile OS vendors, right, to optimize that.